So this leads nicely to the last topic that I want to mention. So I posted the code on GitHub, and you notice that I asked you to read, actually, the word that I wrote last year, but it's, the method itself, being out there for a while, I was trying to write a review paper to summarize some of the key results. But regardless, one thing you probably noticed that is, especially, I mean, for utility measures, it's probably still overall, like in some way, straightforward, that you read the paper about it, and then they talk about, well, you can use a logistic regression to do this, so it's overall still easy to follow and implement to some degree. But I have to mention, I think for the risk evaluation, I mean, the one I'm going to show you today is probably the simplest one in my mind, I think. But still, when people write papers about it, including myself, in the past, that we just talk about what they are, but we never show people how to do it. In a sense, not that we don't want to show, it's like, oh, well, you figure out, and things like that. So that's another thing I noticed in this field, in a way that I would like to, well, for this course, obviously, we're able to talk about it, how to evaluate it, and talk through it, and you can write your own functions and all that. But I definitely see a need in this field if people want to actually practice using whatever people propose in this field. We better figure out ways, either write packages or like present code to others, so people understand, well, yes, those measures, especially the three summaries I'm going to introduce today, they not only make sense on paper, you should also be able to compute them given what you have. Okay, so I will get into the detail a little bit more. So for today, I prepared three general topics. One thing is recap, and then just what we did so far, and then maybe since everybody, pretty much everybody just talked about their project, so I think we have a okay overview of what we're doing and then what we're going to do for the rest of the semester. And then I will talk about the how to do identification disclosure and the risk evaluation. Then I give the example that I posted on GitHub. Okay. All right. So remember when we first started, we talked about disclosure risk. Okay, that was what that lecture was about. We looked at categorical data, and we noticed that if we have certain assumption about the intruder's knowledge about certain individuals in the publicly available sample, then disclosure arises. Especially if you have combination of variables, like of more variables, that will start to make individuals more unique, and then because of that, they're disclosure risk. Okay, if you're working with the original confidential data. And then we had two lectures on Bayesian synthesis models. We talked about joint modeling versus the full conditional specification. The joint synthesis, we didn't dig into too much, but I think I mentioned, like, say, if you have two continuous variables, you can develop a bivariate normal model for it, say the log income and log expenditure, and then go from there. But the main emphasis I think we have so far is about the sequential synthesis, right? Like dealing with one variable at a time, okay? And then that will depend on what kind of, what type of variables you work with. For continuous, you can do normal regression. And categorical, if it's binary, you do logistic regression. Ordered categorical, you do multinomial, logistic, or dirichlet multinomial. Okay. And then if you have ordered categorical, you do probit. Okay. So again, this will require yourself, like, study this a little bit more and then figure out, like, either JAX or some other software to do this. And another thing, I think we mentioned it like briefly, especially I think back then Isaac was working on a different data set, and then there was those counts. So counts can easily be synthesized using Poisson regression. Okay, we learned about the Poisson gamma conjugate back in the Bayesian course. If you remember, Poisson model is usually used for counts, in modeling counts, like occurrences of things. And then it has one parameter, and then that parameter usually gamma is the conjugate type for that parameter. Okay, so I mean, Poisson regression is that kind of parameter. You write a linear function of it with regards to the other predictors that you can do. So that's what we mean by Poisson regression. Okay, so you can take into account of the other variables into this if you want. Okay, so this is the general picture. And then we spent two lectures on utility evaluation. Okay, first one is about the global utility, propensity score, cluster analysis, and empirical CDF. Okay, so those, we talked about what they are, we gave demos, and then I think practice doing that for the CV synthesis. Okay? So that's what we had. And then we most recently just talked about analysis-specific utility. Okay, we talked about, well, categorical variables, how can you think about analysis-specific utility? And then geographic variables, I think I show you like you can do heat map, right? Like I show you like a plot of what I used to do and all that. So happy to share more if that's what we're dealing with. Then we talked about for partial synthesis, how to do combining rules. Okay? For full synthesis, how can we do combining rules? So that's the one that we just talked about. And then lastly, the interval overlap utility. So this is what we talked about. Again, global utility is, I mean, it can be used for any kind of data or any kind of model that you're dealing with. Analysis specific utility is the name, you can tell that it will be based on the analysis that you want to do. Okay? So that can be more specific. And for example, just now when Maggie presented what she was doing, there's this like pie charts about like say what is it like in the original, what is it like in the synthetic version when you're dealing with categorical data. So those will be analysis specific utility. Okay, so be creative. I mean, global utility is definitely something good to do. Like Ted was mentioning that once the model is done, you will do those for the entire data set. Those are looking at the distributional characteristics overall. Okay, but analysis specific should also be a focus as well. So it depends on what you're going to be working with. So keep that in mind. And then we're ready now to talk about disclosure risk evaluation of synthetic data set. In the past, we're talking about disclosure risk on the original as if we have access to the original, right? But now we generate synthetic data set, we want to see how safe it is to release those synthetic data set. So that's what we're trying to do. So going back, if you remember, we talked about two types of disclosure risk: identification disclosure and attribute disclosure. Identification disclosure is looking at, I mean, trying to see how likely it is to identify somebody in the file. Okay, so as you will see, we're gonna talk about three important summaries of identification disclosure: expected match rate, true match rate, and then false match rate. So that's the part that I asked you to read about, and then also use R to compute based on a sample data set I share with you. So in class, we're gonna demo with categorical data. So that was the task I asked you to do. But at the end, I will ask you to think about, well, categorical data, we see how to do it. So how can we brainstorm for continuous data? Because apparently, I think many of you are dealing with synthesis for continuous data. So at the end of the day, you definitely have to figure out in some way how to do identification disclosure for those variables. Okay? And then the other type of disclosure risk is attribute disclosure. That will be guessing or like looking at the probability of correctly inferring the actual value that is being synthesized. Okay, say income, for example. I can see this, say for example, for a particular record in the synthetic data, I can see how much that person is making, right? But maybe instead of how much in the synthetic data, I want to know how much that person is making in the real data. And then trying to guess that is a type of attribute disclosure. Okay, so in that case, I think attribute disclosure will be also very application specific. Okay? So later on, I think after the break, we can talk about some examples, and then you should be also creative in terms of thinking about attribute disclosure in your project. Okay? So those, again, will be more application specific, just like those analysis specific utility measures.